Good afternoon, everyone. My name is Joshua Jorsagli, and I'm here to present my project on fake news detection using machine learning. Misinformation has become a growing issue, especially with the rise of digital media. Fake news can manipulate public opinion, impact elections, and even cause real world harm. Detecting and stopping misinformation is more important than ever. Through this project, I explore how machine learning models can analyze news articles, identify deceptive content, and help reduce the spread of fake news. Today, I'll walk you through the methodology, model performance, challenges, and future improvements in this field. My methodology for fake news detection follows four key steps: dataset collection, pre-processing, model training, and evaluation. I used a labeled dataset for fake and real news articles to train our models. Due to this being a binary classification task, it requires clear annotated data to ensure reliability. Text data was cleaned by removing noise or unwanted data like punctuation and stop words. Lemmatization reduced words to their root forms, for example, running to run, and redundant terms like routers, images, etc. were all filtered out. So some of the models I used are logistic regression. It's a simple linear model that estimates probabilities. It's fast and interpretable, but assumes linear relationships in the data. Decision tree. It splits data into branches based on feature rules, easy to understand but prone to overfitting. Gradient boosting. It builds trees sequentially, correcting errors from previous ones, more robust than a single decision tree. Random forest. A group of decision trees that votes for the final result, reduces overfitting and improves accuracy. LSTM. A deep learning model designed for sequences like text. It captures long-range dependencies in languages, making it a powerful tool for context-heavy tasks, which seemed like the best one in this scenario. So for the evaluation metrics, I measured the accuracy, precision, recall, and the F1 score. There will be a comparison later. So for the EDA part, first up, I have a chart showing the most used words, which indicate fake news based on the training data set. We can see like the most used words were GOP, Mr., even, and American. Next up, we have the most used words, which indicate real news. And in this, we can see that the most used words are said, Washington, it, we, the. So I think this occurred due to it having more real articles. So this might have been one of the case for it. So after testing the 5 models, we have the results here. Keep in mind, when detecting fake news, contextual understanding is very important. So even if a model may have slightly lower scores, it may still be better than others. Okay, so for LSTM, it achieved a 92% accuracy with a strong recall of 94%. So it makes it a good choice for sequential text processing. So while the precision is a bit lower at 91%, it has ability to capture context is very useful for fake news detection. Logistic regression, it performed well in all metrics at 98%. It primarily relies on word level features, but it lacks deep contextual understanding. Decision trees, it achieved 93% on all metrics, but it's a rule based model, so it struggles with complex text patterns. Gradient boosting, 95% in all metrics, but it does very well with subtle text patterns, so it makes it a very good choice. Random forest, while it performs on par with logistic regression, it may not be the best for contextual understanding, as it treats words more independently. While machine learning models have significantly improved fake news detection, they still face several challenges and limitations. The effectiveness of these models is constrained by data biases, evolving misinformation tactics, and the complexity of real-world implementation. Ensuring high accuracy while minimizing false positives remains an ongoing struggle. And we can see some key issues here being dataset bias, evolving fake news patterns, context understanding, computational complexity. So for my future enhancements, I hope to improve the fake news detection, expanding the dataset, using better transformer-based models like BERT and GPT, trying to integrate with real-time detection, and having some multimodal analysis. So in conclusion, this project demonstrated that machine learning models, particularly LSTM and gradient boosting, are effective in detecting fake news. While traditional models offer simplicity and interpretability, Deep learning models provide greater adaptability. To combat misinformation, ongoing advancements in AI and collaboration with fact-checking agencies are crucial. By continuously improving detection models, we can contribute to a more reliable digital news ecosystem. Thank you.